Welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE. Now, in this series, we are going to talk about the analog and digital communication, and primarily we are going to take the questions which has already been asked in GATE 2025. So this is part 1. Since there are many questions has been asked from this particular course, so we will take the few questions and the remaining questions we will take in the another part. So here is detail about the SRM IST, which is ranked on the 14th as per NIRF 2025, just about to the IIT ISM Dhanbad. Here is the overview. So why are we talking about this, the important subjects, that is communication. So this is primarily your core subjects, and the weightage is maybe more than 8, and like in the range of the 8 to 12 marks. So here is the syllabus that I got it from your GATE syllabus that has been published by the IIT Guwahati, as your IIT Guwahati is going to conduct this GATE 2026. So primarily if we will look, then the syllabus is divided into the 4 categories. So first is probability random process based. Analog is the second one is analog communication. Third one is information theory, and finally the digital communication. So in this series, in this session, we are going to take the questions mostly from the analog communication. Okay, so first of all, this GATE 2025 has been conducted by your IIT Roorkee, and so let's take the question. So question number 14 is your consider a frequency modulated FM signal. FT is given. This is your AC cos of twice pi FC t plus 3 sine twice pi F1 t plus 4 sine 6 pi F1 t. This is and so where AC and FC are the respectively the amplitude and frequency of your carrier waveform. So the frequency F1 is in Hertz, and assume that FC is greater than 100 times of F1. Now we have to find out the peak deviation, peak frequency deviation of the FM. So first of all, uh, your as per answer key provided by the direct key, your answer should be the correct answer is A, means 15 times of F1. So what is the challenge here? Challenge is that in this question your f of t is given, means the modulated signal is given here. Now you have to find out the deviation, right? The maximum deviation due to your original signal, that is message signal, right? In this frequency modulated FM signal. So this is your example of the frequency modulated signal, right? Okay, so first of all, uh, why are we talking about this FM signal? So primarily, FM, your modulating signal is actually made by the two types of the signal. First is your modulating signal. Modulating signal means what? Whatever we wanted to send the information from source to destination, definitely the message signal is considered as a modulating signal, right? Means suppose if you wanted to talk with someone using your mobile phone, then whatever you are speaking, that will be the message signal, right? So your voice signal is an example of message signal, but your message signals have the less frequency, and because of having the less frequency, your voice signal cannot propagate to the longer distance, right? So question is that then how it can propagate to the longer distance? So answer is your carrier wave. So carrier wave have the high frequency, very high frequency, and if your modulating wave will load it to the carrier wave, then carrier wave can carry the informations, carry the modulating wave to the longer distance, and in this way you can deliver your message information to the destination. So this is the technique that we are using in the frequency modulating in this type of modulating type of signals, right? So this is the modulating your voice signal, this is your carrier, that is high frequency signal, and this is the FM modulating signal, right? So now here exactly we have to find out the how much deviation, right? So whatever the carrier wave or carrier signals we have, definitely the frequency of your modulating signal is very less, no doubt, but still there will be the some deviation in your carrier signal, right? So question is that how much deviations will be there and maximum how much deviations will be in the FM modulating signal. So we have to find out the del so this is something like that. Suppose if your carrier signal is equivalent to your bus and passengers are equivalent to the modulating signals, so the mass of your bus is much more high compared to mass of your body, right? So now definitely how much the how much effect there will be due to you, the due to the passengers in the bus, so how much mass deviations will be. So like that only we are going to calculate the how much deviations is there. So how will calculate? So very simple, you can calculate using the formula del of f, that is this is nothing, this is your omega d omega by dt. D omega is your twice pi f, so twice pi f, and d omega is nothing, d omega that is a change in the your frequency only, that is d phi by dt. So we have to calculate the maximum, that's all. So we'll use this technique to solve. So let's see how we'll calculate it. So here you can see, first of all your phase is given. So as per your question, your carrier AC cos theta t, cos theta t. So if you'll equivalent, then theta t is this one. In your question it is given. So here twice pi fc, that is omega ct, and this is your omega 1t and omega 2t. So here now the f1 is given and fc is also given. So fc is your carrier and f1 and f2 both are f1 only, so both are the modulating signal only, right? So now we'll calculate the how much modulating signal will deviate from your fc. So we'll use this formula d omega by dt, that is f1 by t is equal to 1 by twice by d theta by dt. So let's find out d theta by dt. This is our challenge. So d theta is already here. So we'll find out the derivative of the d theta by dt. So just do this differentiation. If you'll do, then you will get this values. So here fc is and then divide by your twice by. So you will get the f1t. So how much f1t is? Fc plus 3 of f1 cos twice by f1t plus 12 of f1 cos of 6 by f1t. So here you will get the how much deviations will be here due to this f1t, right? So maximum deviation is equal to how much? Thrice of f1 cos twice by f1t plus 12 f1 cos of 6 by f1t. So how much maximum cos theta will be the 1, right? Plus minus 1, maximum values of cos theta. So since we are calculating the positive, so we can use the plus 1, and here also the cos theta will be plus 1 maximum. So thrice of f1 plus into plus 1 and plus 12 of f1 and plus 1. So finally you will get the 15 of f1. So this is the maximum deviations which will have from this fc, that is the carrier wave. So that is why the del f will be equal to plus minus 15 f1, right? Because cos theta is equal to also maybe possible minus 1, but this one will be the maximum deviation in any way, right? So your final answer is A, that is 15f1 as per answer key provided by the additive key. Now let's take the another question. So in this question, question number 15, it has given the consider an additive white Gaussian noise AWGN channel with bandwidth W and noise power spectral density is N naught by 2. So let P average denote the average transmit power constraints. Which of the following plots illustrate the dependence of the channel capacity C on the bandwidth W, right? So we have in this question what is given? Given is that a channel. What type of channel is there? Additive white Gaussian noise. So AWGN, this is your channel. Channel is what? Like wherever your carrier wave will propagate. with the by in also it will carry the massive signal, that is modulating, right? So actually wherever carrier wave will propagate, that can also be called as a channel. So your air is definitely an example of your channel. So this is your additive white Gaussian noise, where your Gaussian noise will be added. That is why this is called additive. Now, what is bandwidth? Bandwidth is your the difference of the frequency exactly, which is being used to transmit the information from source to destination. So something like pipe only. The what if water is flowing through the some pipe, then so actually whatever the information you are propagating, you can't go beyond these frequency limits. So bandwidth is your frequency limits. So minimum frequency and maximum frequency. So the difference of minimum to maximum is your bandwidth, right? So what are the options are given? So actually you should know the actually what is the requirement. So here you can see you have to plot the graph in between the C to W, C to W, C to W. So what is C? C is the channel capacity, and what is W? W is bandwidth. So bandwidth, so how your bandwidth will vary with respect to the channel capacity that is required. As per answer key, your first answer should be correct, right? So as per the Shannon-Hartley theorem, if you know, then this is the most important, the formula that you should remember. As per the Shannon-Hartley, your channel capacity is depending on the bandwidth using this formula. So C can be written equal to W log of 2 1 plus S of S by N ratio, right? So what is this exactly? What is the noise? So transmitter is there. Transmitter will transmit the information, and your signal will propagate through the channel. But in this channel, additive white Gaussian noise will also be added, right? So some noise is definitely will present in all types of channel, right? So you must have to include that noise. So this part, that is 1 plus S by N, this is only due to the noise only, right? So 1 plus SNR signal to, then you will receive, right? So how much channel capacity is there? So it will be equal to the bandwidth then log of S plus and 1 plus SNR. So how relationship you can find? So capacity versus your bandwidth. So your Shannon limit is there. Beyond Shannon limit, your capacity may not be increased, right? So also you can plot the graph in between the capacity with the SNR. So in order to plot these graphs, you can put the values. Like suppose if I'm trying to plot the in between the C2 W, so W will be equal to 0. In that case, definitely C will be almost 0. There will be the little bit values because of 1 plus this part cannot be 0 here. Okay, so and almost it will be 0, but log 1 is equal to 0. So in that case, but there will this part will not be 0. Of course, signal to noise ratio there will be the something. So we are starting just about to the 0, and then if what will be the maximum value of this part? Even if your W is infinity, your x into 1 plus x divided by x, this part cannot be 0, so it will reach to the some limit that is called Shannon limit. Similarly, put the values of h by n, that is 0 to infinity, and you will get the value. So at the 0, again log 1 is equal to almost 0, and then for Shannon limit it will reach to the highest values. So what is the exactly formula? Formula is C is equal to W log 2 1 plus S by N. So W is bandwidth, S is your signal power, and N is your noise power, right? So remember this formula. This is most important formula, right? In order to find out the channel capacity or the bandwidth dependency in the channel capacity. Especially it will be very valid in the Gaussian noise, right? So now how we'll find out your answer? So behavior, you can find out the behavioral analysis. So at law W, your W equal to 0. Here if you will put W is equal to 0, in this case your cap C will be starts from the 0 and increasing almost linearly, because your SNR, that is P divided by your and SNR will be very high, so it will start linearly, but later at very high W, suppose W is almost infinity, at this case what will happen? your C, definitely C will not be infinity. Why? Because of this logarithm. So in this your capacity does not infinity, it reaches to a theoretical limit that is called Shannon limit, and you can use the limit that is z equal to 0 and log of 1 by x divided by x. So this part will be the divided by x, and 1 plus log of 1 plus x equal to 1. So automatically here C infinity, in this case it will be the values will be 1.44 into p average by n, right? So plot A, so where are the plots? So plot, you can check the first plot here. C is increasing linearly first, from 0 to, in this case, and then it reaches to a Shannon limit, right? So this is the whenever the C is W is increasing continuously, so it will reach to a Shannon limit. So this is correct, and in this case it's a continuously increasing, so right, this equation is not valid here. And in this case also, initially it is not linearly increasing and later it's a keep on increasing, but the value will settle down, right? So it cannot go beyond the certain limit. Here increasing and decreasing also, that is not possible. So your correct option is A. So if you remember this equation, and if you will put the values of W from 0 to infinity, you will get the values of the C and then the curve. So finally your answer A is correct. Okay, now let's take another one more question. So consider a massive signal MT which is band limited to minus W to W, where W is in hertz, right? This is frequency minus some hertz to minus some plus some hertz. Consider the following two modulation scheme for the message. So different types of the modulation. What are they? First is your DSBSC, that is double sideband suppressed carrier. Second one is amplitude modulation, that is AM. A standard one, both are actually AM only, but this is a standard one, this is a special case DSBSC. So here AC and FC are the amplitude and carrier frequency, right? AC and FC. So AC is your amplitude, that is the 1 2 3 4, and FC is your carrier frequency, that may be in hertz, like minus W hertz or whatever in hertz. So in case of AM, mu denotes the modulation index. So in this case, mu is your nothing. Mu is your AM by AC. That is the ratio of the amplitude of massive signal to the amplitude of carrier signal. That is called the what is called this mu. That is modulation index, right? Consider the two statements. Now two statements are given. An envelope detector can be used for demodulation in DSB-SC scheme only if MT is greater than 0 for all t, right? So now actually this is the signals, the transmitting signal. Now they are talking about the demodulation side. These are the transmitter side, and we are talking about the demodulation, that is receiver side. So in the receiver side, uh, empty should be greater than equal to 0 in order to detect it. For which one? So for this case, that is DSBSC. For second case, in this case they are talking that for demodulation in the AM scheme, it will be detected only if empty is less than equal to 0 in this case, right? So as per answer key, your option A and D are correct. So first one is true, second one is false as per answer key. Let's talk about it. So first of all, what do you mean by this double sideband suppressed carrier? So in the in the beginning of this session, we have already discussed what are the carrier, what are the modulating signals. So this is one of the type of the the transmitting technique where double sideband suppressed carrier is being used to transmit the information, that is the message, with the help of the carrier. So here is your carrier wave, carrier frequency, and in this case actually you can see the carrier is suppressed, means both carrier, this time and this time, both in the left side right side, both term you can see there is no carrier, only carrier is at the center. In this case, we in amplitude modulation, carrier is there, and then this is fc minus w, fc plus w, here also fc minus w, fc plus w. So these are the message signals and along with the carrier. So in a standard wave, carrier will be there. In the DSB-SC, there is no carrier along with the message. So this is the advantage. Advantage is why? Because you need to carry this much of power. So the double sideband frequency, this is the equation, that is AC mt cos of twice pi fct, and for your standard AM, so AC 1 plus of mu mt and cos of omega ct, right? So here you can see in terms of the power transmitting, DSB-SC is better than AM. Why? Because there is no carrier frequency, so definitely it requires the less power. Now in this question we are actually talking about the modulation index, right? So I just gave this introduction so that you may understand the meaning of the DSB-SC and why these equations are there. So if you wanted to learn about these things, will bring in this in the upcoming sessions. So basics again, the modulating signal, that is the massive signals, then the carrier signals, so and DSB-SC. So envelope detector is there. So this time your envelope detector actually going to detect the in towards the the detector side. And here is your information, that is AM signal detector. So again here you are going to detect. So in this case, what is the difference here? Here empty, if your detector side your empty is whenever it is greater than 0, definitely you can detect. Definitely it should not be less than 0. If it is less than 0, how will you detect, right? So there will be error. And in this case your AM signal, so your modulation index, that is 1 plus fmt. So this should be equal to greater than 0, otherwise again this part will not be detected, right? So just remember, mt should be greater than 0, 1 plus mu mt should be greater than 0. This part only, then only you can detect the information. So now let's talk about it. So for DSB-SC, your MT should be equal to greater than 0. This should always be positive. It cannot be negative. Otherwise, how amplitude, if you are detecting your amplitude is negative, how will you detect, right? So your first one is true, and for second one, your 1 plus mu mt, it should be greater than equal to 0. But in your option, what is given, that mt should be greater than 0. So 1 plus mt may be 0. For some case, even mt is less than 0. Means suppose mt is mu mt is in between 0 to 1, then this term will be greater than 0, right? Suppose 1 plus and 0.1. So 1 plus minus of 0.5. So in that case, it will be plus 0.5, which will be greater than equal to 0. So for some values of mt, which is maybe in the negative values, still your 1 plus mu mt can be greater than 0. So that is why your option second is not valid. So statement second is false. In summary, here you can see your equation for your DSB-SC, standard MT, and so in envelope detection only MT should be greater than 0, and this is 1 plus mu MT should be greater than 0, right? So carrier is not present, carrier is present here. So option A and D both are correct. Thank you for joining the sessions. If you have any doubts, please drop your comments.